Welcome back, everyone. I'm so excited to have you here for this module in our Spring RestClient Explainer series. If you've been following along in our full Spring RestClient setup, headers, query parameters, and timeouts playlist, you know we're building up our skills piece by piece. Today, we're taking on a super practical, real-world challenge that we face all the time as senior developers, handling complex per-request configurations. Let's get right into it.
Here's our roadmap for today's session. First, reviewing our post-service setup. Second, handling multiple headers per request. Third, deciding which API to choose. Fourth, a nice little bonus on typed helpers. And finally, our summary and next steps.
Okay, Section 1. Reviewing post-service setup.
Let's do a quick refresher on the code we already have. We've laid down a really solid foundation for our GET requests in our post service. We tackled single query parameters in GET posts by user by passing user ID right into the URI builder. Then we handled multiple query parameters in search posts just by chaining .queryParam as many times as we needed to. And finally, down at the bottom, we nailed path variables in GetPost by passing the ID directly into the URI string /posts/ID. But up until now, we've only been retrieving data. It's time to actually send some data, and we need to do it with some very specific context attached.
That brings us to Section 2. Multiple headers per request.
To handle these per-request headers, we're going to make a post call. Let's write out our new method signature step by step. We'll start with public post create post, opening our parentheses to take in the post payload itself, plus a string request ID and a string trace ID. Inside the method, we kick things off by returning RestClient.post open and close parentheses. We are officially shifting gears from getting data to creating it.
Next up in our method chain, we need to specify our endpoint. So we append .URI, passing in the string /posts. And because we're sending data up to the server, we absolutely have to tell it what kind of data to expect. So we chain .content-type, passing in mediatype.application_JSON. This explicitly guarantees our payload is formatted as JSON.
Now for the really crucial part. How do we actually add multiple headers without making a mess? We use the .headers method, but we pass it a consumer block, which is essentially just a lambda expression. We write .headers, open parentheses, and then write headers, an arrow, and an open curly brace. This gives us direct access to the HTTP headers object, letting us bundle all of our header logic into one super clean, manageable block, instead of just chaining endless single headers over and over.
Inside this block, let's map out our custom IDs. We use headers.set and pass in our key value pairs. First, we write headers.set, passing in the string x-request_id and our requested variable. Then headers.set for x trace ID and our trace ID variable. And just for fun, let's hard code an origin identifier. Headers.set, passing in x source and the string RestClient demo. This is actually a fantastic real-world enterprise scenario. Headers like x-request_id and x-trace_id are literally the backbone for distributed tracing. By doing this, if our request travels through 10 different microservices, we can track it the whole way.
All right, let's finish this off. We close out our headers block with a closing curly brace and parentheses. Then we attach our actual payload using .body, passing in our post object. Finally, we tell Spring to execute the request with .retrieve open and close parentheses, and we map the incoming response directly back into our application using .body, passing in post.class. We drop our final closing curly brace, and just like that, we have an incredibly robust, production-ready post method.
Moving on to Section 3. Which API to choose?
You know, writing the code is really only half the battle. Knowing exactly when to choose a specific approach is what makes you a senior developer. Let's look at the decision matrix we use to make that architectural choice.
Let's break this down. First, if you have a header that is exactly the same for every single call made through this REST client, like a global API key, you should use .default header, passing in the name and value right on the builder when you first construct the client. Second, if you just need to add one or two simple headers to a single call, using the standard .header method per request is perfect. It's fast and highly readable. But third, when you need to set several headers at once, or, and this is key, if you need to branch on logic, like using an if statement to conditionally set a header, that is exactly when you reach for the .headers consumer form that we just built together.
Now for Section 4. Bonus, typed helper methods.
I love this feature. It's a massive bonus to using that consumer form. Because it hands you the HTTP headers object directly, It unlocks Spring's typed helper methods. This means instead of relying on super error-prone strings where you manually type out authorization, followed by bearer, and then concatenating your token, and just crossing your fingers that you didn't miss a space or misspell a word, you can simply call headers.setBearerAuth, passing in your token. Or you can use headers.setBasicAuth for a user and password, or setIfNoneMatch for an e-tag. It completely eliminates the risk of handwriting string formats and makes your code so much more resilient and type-safe.
All right, Section 5, Summary and Next Steps. Let's recap what we've accomplished. We constructed a brand new createPost method right alongside our existing getRequests. We seamlessly handled multiple dynamic per-request headers using the .headers consumer block. We evaluated the API decision matrix, so now you know exactly when to reach for default headers versus per-request headers. And finally, we unlocked those gorgeous typed helper methods to make our authorization headers perfectly safe from typos. We basically handled complex enterprise headers without cluttering our code at all.
Make sure you check out the detailed article link in the description below for a written walkthrough of all this code. It's a really great reference to keep open in your IDE. As you look at your own projects today, I want to leave you with this. How will you structure your next complex API integration, now that you have these powerful header strategies in your toolkit? Thank you so much for learning with me today. In the next part, wiring it up and running it.